Alright, grade 12s, let's look at the multiple choice for the control test in term 2. So question 1 says, which of the following equations represent the principle of conservation of mechanical energy? So we're looking at the conservation of mechanical energy, and before you even look at the options, you need to remember that the conservation of mechanical energy means that the mechanical energy at one point is equal to the mechanical energy at the bottom. Now, if you look at these options, none of these options are written exactly like that. They talk about EP, they talk about EK, so we have to remember that this would be EK initial plus EP initial would then become EK final plus EP final. Now, when I look at this, there's nothing to do with work done by non-conservative force. The only way mechanical energy can be conserved is if there's no external forces. So that means, right, we can't use any of those because those all include something to do with mechanical energy. Well, with non-conservative. So they're saying that there's friction or applied force being applied, which isn't the case. Then, if we look at C as an option, well, both of those have EP. They have nothing to do with EK, so it definitely can't be that one. That means it has to be B. But now, let me show you that actually B works. So, if I have EK initial plus EP initial equal to EK final plus EP final. I'm going to take the EK over, so this becomes EK initial minus EK final equal to EP final minus EP initial. This isn't changing EK yet because it's always got to be final minus initial. So if I take the minus out. Alright, so this becomes negative, changing EK is equal to change in EP, which is exactly what that was. Okay, right. Question 2. An object moving at that wouldn't be a good idea. Constant velocity encounters a rough horizontal surface, friction. The object continues to move over this rough surface. The net work done on the object during the motion on the rough surface is. So in other words, now there's friction, so we're going to do work done by friction, which is always negative. Okay. The work done is completely only by friction. It's moving horizontally. If it's going at constant velocity, there's no applied forces to it. It has to be negative because it's work done by friction, and work done by friction is always negative. So that's C. Then we get to question 1.3. Now I'm just going to make this a bit smaller, and it says to you, the pressure versus time graph below represents a sound wave in air emitted by a stationary source. Which one of the following graphs best represents the sound wave observed by a stationary observer if the source is moving away? So now remember, if a source is moving away, wavelength increases, so frequency decreases. The wave has to get longer, not higher, longer. So here I have 1, 2, 2.5 waves. Okay, so all about the same size, and I look at this and go, well, this is 1.5, so maybe it means that in the same space I've got a longer wave. This is also 1.5, so this is an option, this is an option. Here, I've got lots. I've got 1, 2, 3, 4, so it's not that. That means the frequency is increased. Here, I've got 1, 2, 1.5, so that's the same frequency. That doesn't help. Now, we have to look at the size of the wave. Okay, so now I'm going to take this out because what's really important is for us to realize that amplitude doesn't change. So if we look at this one and we go, Alright, this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bars high. Okay, let's look here. This is 1, 2, 3, 4, 5, 6, 7. That's only 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My answer has to be D. Yes, my wave, I've got a longer wave, so frequency is decreased, but it's the same amplitude. Amplitude doesn't change. Okay, it's D. Then, the weight of an object on the Earth is W. What will the weight of the object on the surface of another planet be of the same mass, but twice the radius? Okay, so now remember, F equals G, mass of the object, mass of the planet, R squared. Okay, and on Earth that happens to be W. When we get to the surface of this new planet, we still have G, M, M, but now this is 2 times the radius of the Earth. Okay, so that's G, M, M over 4R squared. I'm going to take the 4 out. We get G, M, M over R squared. Alright, this equals to W, so it's a quarter W. That makes it D as well. Okay, number 5. There we go. A trolley is pushed along a horizontal surface with a force of 150 newtons at 45 degrees. The trolley experiences a constant frictional force of 60 newtons. So, the net force acting on the trolley causes the trolley to accelerate horizontally. Okay, so we've got to go, well, the force that's going to make it go this way is my horizontal force, which is F, and it's going to be going down like that. So there's my 45. That means it's F cos theta, so it's 150 cos 45. Okay, and when we look at that and we put that into our calculators, cos 45, that is 106,07. So the net force acting on my trolley is 106,07 minus 60, because it's in the opposite direction, so it's 46,07 newtons to the right. So the net force causes the trolley to accelerate horizontally, absolutely. Is equal to the applied force? No, because the applied force is 106, so no. Is horizontally forward? Yes, of course it is. So which statements are correct? We said 1 and 3. When we look at all the options, that option then is B. Okay? Alright. Which one of the following will rapidly decolorize bromine water? So what we're looking for is an alkene or an alkyne. Okay, so if we look at this first one, CH3, CH, CH2, that shouldn't be there. That means we have a double bond, that definitely. Then we have CH3, CH2, CH2, no. This is an ester, definitely not. Carboxylic acid, definitely not. A is my alkene, it has to be A. Alright. Then, 1.7. Which one of the following alcohols will be able to undergo a substitution reaction at room temperature? Okay, well, we have primary alcohol, secondary alcohol, primary alcohol, tertiary alcohol. Okay, primary, 1. Secondary, it's on the second one. Ethanol is always a primary, can't be anything else. This is tertiary because it's butane, right? And on the second one is the OH, and then we have a CH3. So this is definitely the one that will undergo substitution at room temperature. The OH will come off, so it has to be D. Okay? Now, 1.8, you actually had two options because we forgot something in the question, but we'll go with it. It says to you, graph Q, the solid line, so here's my solid line, that's graph Q, was obtained for the reaction of magnesium powder with 0.1 mole per decimeter cubed of acetic acid. Which graph most probably represents the reaction with 1 mole of per decimeter cubed? So what have we done? We've increased the concentration. Okay? So first of all, that means it can't be B and a C and it can't be D. Those rates are slower. Now we look at the options. What we actually wanted was for you to tell us that it was going to be B, this one. Okay? That would be the first option because we've increased concentration, so the concentration, it's going to get faster. But now we didn't tell you what was in excess and we didn't tell you the volume of the amount of acetic acid. Those actually would determine whether we get the same amount of product or not. Now, if we kept everything the same, so we used the same volume, we used the same amount of magnesium powder, but we didn't tell you that the acetic acid was in excess, okay, it is possible for us to get A as well, okay? We should have told you that the acetic acid was in excess. By telling you it's in excess, the amount of product we get is determined by the magnesium. We didn't tell you that. So we accepted A or B for this question because both of them tell me that you understand that the reaction got faster. That was what we were looking for. Okay? Then, 50 centimeters cubed of a 0.1 mole per decimeter cube solution of hydrochloric acid is added to 5 grams of granulated zinc, which is inside a glass beaker at room temperature. Which of the following factors will not increase the initial rate? So, let's see what we've got. 100 centimeters cubed of 0.1. All we've done is changed volume. That probably won't, no. Using 30 centimeters cubed of 0.2, absolutely, I've got an increase in concentration, so it's not that. Increasing the temperature always increases rate. Grinding the granulated zinc into powder, well, powder will increase the rate, so it's not that one. It's definitely A. Alright? Last question, 1.10. The graph represents the change in the rate of reaction versus time for a reversible reaction that took place with an amount of hydrogen, iodine sealed in a container. Now here you've seen this reaction lots by now. The equilibrium was first reached after 5 seconds. What change was made at 10 minutes to change the rate of the reaction as indicated? This one is one of those things you should know. First of all, okay, we have the same number of molecules on both sides. So pressure might be an issue here, but they tell you external pressure was decreased. By decreasing the pressure, we will make it go slower. So this tells me the reaction rate was going faster, so it's not a decrease in pressure. Secondly, when we look at the temperature was increased or decreased, well, temperature would never result in a spike. Okay, and temperature will not result in them both ending up in the same place because this is an exothermic forward reaction, so changing temperature will favor one or other of the reactions. That means D is my only option. A catalyst is used because a catalyst spikes both reactions and it reaches equilibrium faster. Just when it gets to equilibrium, it's also going to be going at a faster rate. Okay, so that's the multiple choice.